Hi, Jacob. I was reading your email and I saw you had questions about how to get two solutions for a lot of our trig equations where we're trying to solve out for critical points. So I thought I would show an example of each one of our major three trig functions and discuss how to get both solutions out of there. For most people, if they had to solve the equation, the sine of x is equal to 1/2, sadly, a lot of people would go to their calculator and say x equals the inverse sine of 1/2. If you did that, or if you know, we know that there's an angle pi over 6 in quadrant 1 where the cosine is the square root of 3 over 2 and the sine is 1/2. But now, what I literally need you to think about if you're solving for these critical points in the mean value theorem problems is that, yeah, that is one solution, but just saying that the sine of x is 1/2 doesn't restrict it to being quadrant 1. There is another value in which the sine is 1/2 because the sine literally means the y component on the unit circle is 1/2. So the y component on the unit circle is 1/2 over here as well. And you'd say, well, this angle has to be the same angular distance to the x-axis. So if that's pi over 6, we know this is pi over 6. Pi is the same thing as 6 pi over 6. So this angle is 5 pi over 6. So we would know at 5 pi over 6 that the cosine is the negative square root of 3 over 2. The sine is also 1/2. So you'd have your two angles if you're trying to solve out this equation. Similarly, if I were trying to find the critical points that come from the factor when the cosine of x is equal to the negative square root of 3 over 2, well, as a decimal, negative square root of 3 over 2 is approximately negative 0.866. So all that means is that the x component on your unit circle is pretty close to -1. It's negative 0.866. So I drew that here. If this is 0 and this is -1, the negative square root of 3 over 2 is approximately right here. Now, the angles on my unit circle that are going to have that negative of an x component are these two angles. Now, again, if some students just went to their calculator, please remember our inverse trig functions are only capable of giving us one answer because they're a function. For every input, there must be exactly one output. So it's going to restrict the cosine function to be between 0 and pi. So it's going to give you this answer here, again, 5 pi over 6, because we know that at 5 pi over 6, our cosine is the negative square root of 3 over 2. Our sine, again, is 1/2. And so you'd say, well, all right, that's valid for one. How am I supposed to know the other? Well, you're supposed to have a good working knowledge of the unit circle and say that, yeah, if there's that cosine at 5 pi over 6, it's also that negative x component at the same angular distance from the x-axis. This is pi over 6 short of pi, so this is pi over 6 beyond pi. It's 7 pi over 6. At 7 pi over 6, your cosine would be the negative square root of 3 over 2 again, and of course your sine would be a negative 1/2. Now, for the last case, I think the two cases with the sine and cosine, we can handle that for you if you just think sine is the y component. So whatever y value you're setting it equal to, draw that. If it were negative square root of 3 over 2, you know you're going to be way down here. Your angles would be 4 pi over 3 and 5 pi over 3. Cosine, if I did something like, well, what about the cosine of square root of 2 over 2? You'd be at pi over 4 or down here at 7 pi over 4. Those would be the two values within your first revolution. Now the tangent, you've got to think the ratio of sine to cosine, or the y over the x. So if I ask you, at what 2 points is the tangent of x equal to the square root of 3? Again, a lot of students would just be lazy and say, well, I'm just going to do x is equal to the inverse tangent of the root of 3. The problem with that is it's only going to give them this angle in quadrant 1. It's going to give them an angle of pi over 3. In order to think about that more better, you should just be thinking, okay, we're never going to be asked any of the angles that we're not familiar with. If I'm supposed to know when is the tangent the root of 3, you say, okay, the ratio of y over x has to be greater than 1. the only angle in quadrant 1 and where the y value goes up more than the x value is this angle of pi over 3. And at pi over 3, we know the x component, and you can trace it down. Yeah, the x component goes over half the distance. The x component is 1/2. The y component, if you trace that over, it almost goes up the full distance. It's the square root of 3 over 2. And so clearly, the ratio of the y over the x at that value, yeah, it's the square root of 3. So the tangent of pi over 3 is the square root of 3. Now, where's the other value on the unit circle where this tangent is going to equal the root of 3? Because you were saying you could get one angle, the other angle. For sine and cosine, it's as easy as drawing a horizontal value to find the other y value or drawing a vertical to find the other x value. With tangent, it's always pi radians away. And think about why. Because if I always add pi radians to whatever angle the answer is, in this case, pi over 3 plus 3 pi over 3 would give me 4 pi over 3. At 4 pi over 3, we are going down more than we're going to the left. And you can say, yeah, I'm going to the left a half a unit. I'm going down negative square root of 3 over 2 units. But if you take that ratio, the negative over a negative, of course, we still get the positive, where you say, yeah, okay, the tangent's going to be positive the root of 3 there as well. Okay, hope this helps. Let me know if this wasn't what you're asking. I think this is in relation to what you were asking, trying to find the critical points. But let me know if it's not, and I'll be glad to try to help some more.